Welcome back, friends. So far in our course we have introduced you to the urban transportation systems and some of its challenges. In this lecture we are going to give you an overview of how urban transportation systems are designed, or how they are the demand is determined, so that you are able to build the necessary capacity in your city. So, the demand modeling overview we will show you the different different types of models that are used. We will tell you the importance of supply and demand in transportation modeling, and take you through the most popular model, which is called the 4-step model, which is used in determining the demand, and finally understanding how many lanes, for example, to build in your transportation network. And we will let you know about how to go about and conducting these surveys, which will give you actually the data that is needed to develop these models. Now, this section is a very brief overview of the transportation modeling process. You have separate lectures, NPTEL lecture courses that provides you detailed information about the transportation planning process and the modeling process. However, this course we would at least like you to be aware of these kind of modeling techniques, so that if you are more and more interested about these modeling techniques, then you can go ahead and take the different in-depth courses that are available on this. So, when we are looking at transportation modeling, essentially what we are trying to do is we are trying to understand where do people come from and where do people want to go, right, and which route they want to take. So, we want to know where people are staying, where they want to go to, which route they want to take, and also what is the vehicle usually they want to go or they want to prefer to use, right. Do they want to use their own private vehicles, cars or two-wheelers, or do they want to go on a bus, do they want to take metro. So, if you kind of combine these 4 aspects of the need to travel, that you would be able to determine at a macro level what is the demand for transportation in your city, and based on the demand you can then provide for the capacity, or you can provide for the number of lanes in a road, or the number of bus routes in a city, or the frequency of your metro rail, and so on and so forth. So, that is essentially what we would want you to be aware of when we are talking about transportation modeling. I mean, modeling in general, what a model essentially indicates is that it's a replica of the actual system or the actual network, right. You can build a physical model, right. You can build a miniature car which looks like an actual car. You can have a symbolic model which determines a complex system using different symbols maybe, or you can have mathematical statistical models which by the use of equations and different types of parameters try to explain how a system works. So, when we are talking about transportation modeling, we are essentially talking about mathematical models. So, this concept of travel supply and demand. So, this is essential to the understanding of transportation modeling. Sorry, this is essential to the understanding of the transportation modeling. So, now the supply side of it is the availability of the roads in our city. So, that is an example of supply. So, I have n kilometers of road in my city. So, that is the supply of the transportation network. Or another example would be, I have 49 bus routes in my city. Each of those bus routes have a bus frequency of 1 bus in every 10 minutes. So, that tells me that you know the capacity of the bus, right, and you know that every bus comes in every 10 minutes, one bus comes in every 10 minutes, and you have 49 such routes, then you know the capacity that the bus network can carry. So, that is like the supply side of things. Now, when you talk about the demand side of things, then you say that okay, now you have for example n kilometers of highway, but how many actual vehicles are there in your city that will use these highways, right, and for how much time will they use it, right, how much time or how many kilometers will they drive. So, and you have to know both. You have to it's easy to know the supply side because it's actually either existing or it is planned. So, you know that well, in the next 5 years I am going to build n kilometers of roads, or I am going to have n number of buses, new buses in my fleet. But when it comes to demand, you almost cannot absolutely know what the demand is, right. There may be new vehicles, people coming into the city buying new vehicles. So, you actually cannot accurately predict, or you cannot accurately count the demand. So, what you essentially end up doing is you end up estimating the demand. So, when you are trying to estimate a demand, that is where all the models or the demand models come into play. So, when you look at the supply and demand curve, it's a classic economic example of for anything, for any entity, when you look at the cost versus volume, you say that if the supply of certain things, so the volume of certain things increase, the cost of it also starts increasing, right. So, if something is selling very well, right, if cost is very if suddenly for example a person manufacturing soap starts seeing that these soaps are selling very well. So, he increases the manufacturing, or he increases the volume of the soaps manufactured, and also more and more people get into the soap manufacturing business. So, the cost that he gets out of selling these soaps keeps on increasing. So, the supply keeps on increasing. The supply is always the upward moving, upward sloping curve, whereas demand, so as the volume of goods starts increasing from the demand side, so people who want to use the soaps, the cost for them starts decreasing, right. So, competition brings down the cost for them. So, that is the always a downward sloping. So, similarly, when you are looking supply and demand from the point of view of transportation, you say that when you provide for multiple transportation systems in your city, usually the cost of traveling goes down. When you only provide for one type of transportation, for example, private transportation, private motorized transportation, so then what happens is the cost for travel always remains high or keeps on increasing. So, always the demand decreases as competition, or the price for entity decreases as competition increases. So, you are always encouraged to have a multimodal transportation network in your city, which will eventually bring down the costs for your users. So, when you look at the transportation demand modeling, it aims to establish the spatial distribution of travel explicitly by means of appropriate system of zones. So, what usually we will look at it in the next slide in a step by step manner, but what essentially we are saying is that your city could be vast, right. So, to exactly know where people are traveling to and from may be very difficult, but on a macro level, on an overall level, you can say that people usually in the morning would travel from where they live to where they work. So, if you know the land uses, predominantly residential land uses and the predominantly commercial or office land uses. So, you would know, or you could predict with certain degree of accuracy that the traffic will flow in a direction which is from the residences to the office buildings, and similarly in the evening it will be the opposite traffic flow. So, that is kind of at a macro level your prediction is accurate. However, it becomes very difficult to predict it during the middle of the day and also during the weekends, right. It is weekends, people take a lot of leisure trips. In the middle of the day, the trips are usually taken by non-commuters. So, when non-commuters, meaning non-office goers, make their trips, then you really have a difficulty in predicting where they are going, and you need very high data about the land uses and the trip purposes to predict exactly where people are going, so that you ensure that you provide adequate capacity of your transportation systems to meet the needs of the traveling people. So, in here what we will give you a brief overview of is the most popular 4-step model of travel demand estimation, right. This is popularly called the 4-stage model, and the first stage in this is what is called trip generation. The second step is trip distribution. Third step is understanding the modal split or the choice of mode that you want to take, and finally what is the transportation network that you will be using when you are going from your origin to your destination. So, by knowing these four steps, you can at a macro level, at a city level, or at a municipality level, understand where your traffic needs are, where your transportation needs are. So, let us look at each one of them one by one, but before that, of course, you have to have certain amount of data that feeds into acts as input or feeds into your model. So, you have to know what is the existing network that you are working on. You have to know how many vehicles currently run on your network, and you also have to know some future planning based on the comprehensive plans that are available, comprehensive mobility plans that are available for your city, or the city's master plan, which must have incorporated a 20-30 year horizon plan, which must have incorporated how many roads there will be, how many kilometers of roads there will be 20 years down the line. So, all of that information has to be fed into this model as an input, and then this model would be able to predict that how many trips or how many vehicles will be on the road in the next year, 5 years down the line, and so on and so forth. So, the model starts, if I were to give you a basic example or a very explanation of this in a nutshell, the first step in this is trip generation. And for trip generation, usually what you develop is a small zone of your city, which are usually called TAZs, traffic analysis zones. So, you divide the entire city into different types of traffic analysis zones, and this is called a macro model because now it is going to use this zone at a macro level to predict how many trips are entering and exiting this zone. So, remember, we are not doing it at a micro level. So, we are not tracking everybody's movement to realize to predict how many trips are going to be coming out of or coming onto the network, but we are doing it at a macro level, at a level of a traffic analysis zone. So, we divide, first of all we divide it into all of these zones, and then we look for all the socioeconomic data for the families that are living within that zone itself, right. That acts as an input. Then we look at all the highway network or the roadway network within that zone. We look at the socioeconomic data and so on and so forth, so that it can be fed into the model. Several types of surveys need to be conducted in order to get all this information. You have to conduct household surveys, right. So, household travel surveys are very similar to your census surveys that are done. Census surveys that are done where a surveyor would come to your household and ask you a certain number of questions about typical trips that you take during a weekday or a weekend. So these obviously are anonymized. There is no information about, there is no data about who you are or what your identification is. The data is just required for different categories of households. So households by income, households by age group, households by number of cars you own. So the data is categorized in that manner rather than with any of your personal information. So that is one type of survey that is conducted. The other type of surveys that are conducted include traffic data collection along roadway networks. So you would have to have an information about what is the existing volume of traffic on your highways. So in order to do that, you have to collect data about the traffic volume on your roadway network. Nowadays, like I had mentioned earlier, you have cameras throughout your transportation systems, which makes it easier to at least gather this data. So once you have collected this data, you have to analyze it, you have to clean the data and convert it into information, which will let you know that the number of trips that are being taken, the direction of travel, the traffic flow and the speed. So all of these estimates can be made once you acquire or collect this kind of data. Along with it, you have to you have to have data on your land use inventory, which can be collected from urban local bodies, the housing density in commercial, residential, industrial zones, that has to be also collected. And of course, you have to know your base skeleton network data about your highway, about your roads and highways in the TAZ. So let us always remember that we are all collecting this at a traffic analysis zone level. So once you divide your city into different analysis zones, for each of these zones you will have to have these kind of information. Now what the 4-step model does in the first step is that it estimates how many trips are being generated from each of those TAZs, right. So this is a zone 1 meaning, or zone I meaning, that is one of the traffic analysis zones. So what it essentially does is just counts the number of trips that are coming in and the number of trips that are going out. So in other ways, you can say that these are production trips that are going out and these are attraction trips that are coming in. So a trip is just a one way travel between point A to point B. It is not a round trip. It's just a one-way trip. So this is one trip and this is the other trip, and if any trip is being produced is an outward trip, it is called a production trip, whereas anything that is an inward trip, the zone is called an attraction trip. So the first step in the 4-step model only does that. It develops an estimate for the number of trips that are generated, or meaning produced and attracted by any particular zone. Then once you know that, the second step, or the trip distribution step, what it says is that now that this trip now that we know how many trips are being generated, we have to assign those trips to other zones, right. Now if the trip is being produced from this zone, it must be going to another zone. So which is that zone, right. So we need to assign it to that zone. Similarly, if a trip is being attracted to this zone, it must have been produced in some other zone. So where is this trip coming from? So the trip distribution model kind of predicts that. It predicts where these trips that have been generated are coming from or going to. So usually the most common model that it develops is the gravity model. So it says that trips between two zones are directly dependent upon the attractions that are available in the other zone and the distance or travel time or one of the other between those two. So, if there are a lot of attractions in a zone, it is likely that a trip that is produced in one zone is being attracted to that zone. So, attractions meaning an attraction could be a movie theater, a park, a restaurant, or number of restaurants. So, usually if you want to say that residential zones are usually production zones in the morning, and office areas are normally the attraction zones in the morning, and whereas in the evening they reverse back, and so the office zones become the production zones, and the home zones become the residential zones become the attraction zones. So, that is what the trip generation or the trip distribution model does. In the next step, once you know where these trips are going to, between which zones are the majority of the trips going, it is essential to understand how they are going there. So, are they going using two-wheelers, using four-wheelers, using metro rail, are they walking to these zones, are they using their bicycles? So, what is the choice of mode that they are taking up in order to travel from this zone to that zone? So, that is a step called modal split. And finally, once you know the zones that they are going to and the mode that they are using, you can assign that trip to the network that you already have. So, you can say that okay, to go from A to B, there is no direct metro route. So, it is likely that this person will take his or her private vehicle, and this is the road or the shortest travel time road between these two zones. So, let me assign this trip to that network. So, essentially now you will know that a particular trip that was generated in one zone is being attracted by another zone or is distributed to that zone and is using a personal automobile, then you can easily assign it on a network. So, that is the last step in the 4-step model. Essentially, we have talked about this. The mode choice model, again the most common model that is used currently used are utility based models. So, it says that it calculates the probability of using a mode of transport. So, in this case it is a discrete choice model. So, when we say it is a discrete choice model, because what we mean to say is that everybody has their own choices. So, we cannot say that something another person's choice will affect my choice. We cannot say that. We say that their choice is discrete to my choice. So, and how do we use these utility models is that we weigh the different options that are available to us, and whichever has the least negative utility or the highest positive utility, we use that model. So, the different utility parameters could be time, cost, comfort, and so on and so forth. So, whatever we feel that are compelling factors for us to take that mode, right. If I am a low income person, to me the compelling parameter could be the cost of travel from point A to point B. So, I would look for the cheapest available mode of transport in order for me to go to my destination. Whereas, if I am a middle class or a upper class citizen, then I would maybe give more weightage or give more weightage to comfort or travel time. So, I want to get there early, right. So, then I would maybe pay a premium fee to take a mode that will ensure that I reach my destination on time and very quickly. So, all these things, all these factors works in the background when you are trying to establish the probability of the mode that you are going to use. And finally, like I said, if you are if this is your entire network of streets that are available, and you are trying to go from zone A to zone H, and you know that these are all the streets that are available to you, your trip would be assigned based on your origin zone and your destination zone and the mode of travel that you have chosen. You will then be assigned to a network which takes you to your destination in the shortest amount of time, for example. So, this is the route assignment is one of the popular models is called an all or nothing model. So, like I said, this is in this class we are not going to go into details about how do you develop these models because there are other NPTEL courses that go into that. But however, when you are talking about urban multimodal transportation systems, you have to be aware of the modeling that goes behind the development of these statistical models or mathematical models, how they are developed, what are the parameters. You have to at least have an idea about it, otherwise you will not be able to follow the next few lectures or the lectures throughout this class. Surveys, like I said, most of the surveys are usually done via questionnaires, household surveys. However, you could also do telephonic surveys if you have, if you have enough funds. This again depends on how complex your transportation system is, how big your city is. If you really have funds to do it, you can do much more pinpointed telephonic surveys. You could also use mailbox surveys, which is sending out the survey questionnaire via mail and requesting the user to send it back. This is not much used nowadays, but used to be used in the past. Face-to-face household surveys are something that is done very often, and in some cases you also do roadside interviews where essentially you want to know the mode choice behavior. So, what mode to use, what mode people do use for this particular trip. So, it is sometimes advisable to catch people on their way to a particular destination, so that they remember in their mind exactly what trip, which mode they are using. So, many of the times you would see that people are conducting surveys at bus stops or at rail stations to just understand the behavior of to understand your travel behavior or your mode choice behavior. And cordon and screen line counts are done to determine the volume of the existing volume of traffic on the network. So, if you have a network, you draw a cordon around that network and you count the vehicle that is coming into the cordon and the number of vehicles that is going out of the cordon. So, then you know essentially how many vehicles are there within the cordon at a given point in time. So, that tells you the existing volume of vehicles in your roadway network. So, that kind of a survey is called a cordon or a screen line survey. So, that was about that was an overview of the transportation travel demand modeling surveys, travel demand modeling steps that are involved, from trip generation to trip assignment, and also how these surveys are administered. So, it is essential for you to at least get an overview of these. As we move along in this class, you would then be able to follow as to how these capacity of different transportation systems are calculated. Thank you very much for your time.